Hello, everyone, and thank you for joining today's session. My name is Askia, and I'm the Facilities Coordinator for the Redmond Reactor space. Before we start, I have a few things to go over. Please take a moment to take a look at our Code of Conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared throughout the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel, which brings us to today's session. It will run approximately for 1 hour with time for questions throughout. So I will now turn it over to our speakers.
Greetings. Hello, everyone. My name is Brian Benz, and I'm a cloud advocate at Microsoft. So today's topic is cloud scale data for Spring developers, and it's based on this ebook that you see on the screen here. So what I'm going to do is I'm going to go through the ebook, and I'm going to show you the finished application in Azure as well. And I'm going to show you how you get there. Now, we've only got about an hour, so I won't be able to give you all the details, but they are in the ebook. So we're going to get as far as we can, and we'll probably have another installment of this, make it into a series based on however far we get today. All right, so basically the cloud scale data for Java, cloud scale data for Spring developers ebook is at aka.ms/Azure Spring Java Guide. You can find it there, and that's what everything is based on today. We're going to start with just going through the forward a little bit, what's covered and what's not covered. And I'm not going to read the whole book to you, obviously, but we'll just go through a few things. So basically, we've got this app. It's called the Contoso Pet Supplies app. It's a website. And you can manage different parts of the application itself. It's built on Cosmos DB, and it's built basically through what's called an Azure App Service. And I'm going to introduce each one of these things as we go along and tell you how they're actually built. Introduction to NoSQL. I'm going to go through this really quick because I think most people already have a good handle on NoSQL in general. But basically, it's a JSON-based storage model, which allows you to access data without indexes and without schemas, and is really handy for any kind of data that's what they call unstructured data, which is data that has a flexible structure, let's call it. It still has a little bit of structure, but all the data documents are in JSON, and if something's missing, it's not a big deal. As you know, as compared to SQL, where you have very rigid rules as where the actual structure of the data is concerned. So that's all I'm going to say about NoSQL. Here's a sample JSON document that gets stored in NoSQL, and Azure Cosmos DB is our multi-model database which stores NoSQL data. Now, for the introduction to Cosmos DB, it's in the ebook at aka.ms/Azure Spring Java Guide. But I'm actually going to switch to a presentation, which just makes it easier to look at things. All right. So we're going to cover an introduction to Azure Cosmos DB. I'm going to talk to you about a resource model, the request units, which is how we actually build things, which I'll go over really quickly, but it's important to know. And we'll talk about global distribution and security as well. And then we're going to have a demo. It's more of a walkthrough of some of the things I've already built, and then I'll share some resources with you at the end too. So, intro to Cosmos DB. What is Cosmos DB? It's a NoSQL database at its heart, but it also can store data that can be accessed through SQL. So the data itself is stored in a container. I'll get to that in a minute, but you can store different models in your database. You create something called an account, and then you create a container, and each one of those containers can be a flavor similar to what you see along the top of this slide with a basic table, SQL, JavaScript. There's a MongoDB API. There's one for Cassandra as well. Gremlin, great for graph manipulation. And down at the bottom here, you'll see the different types of models you can use with each one of these flavors of containers. There's key values, column family, documents, and graph. And there's several features which we'll cover in a bit. So one of the big features of Cosmos DB is that it has a global presence. This map is probably already out of date, but you can set up a database in different locations all around the world, and they can replicate with each other. And depending on your consistency model, which we'll mention in a bit, you can have really good consistency for your applications. So it's a great backend for your web-based applications and also for streaming and other things like that. Our SLAs, so we have less than 10 milliseconds for latency. We have high availability. We have guaranteed throughput and guaranteed consistency. And that is flexible depending on the model that you use for your data consistency. And I'll cover that in a bit as well. So the resource model is very important. I mentioned before that you can have multiple containers that support different models of data. The database account is the lowest common denominator for a Cosmos DB database. The database account itself is just something you use for storing your containers, your databases and your containers. So you create an account, you create a database, and then you create a container. And at the container level, that's where you decide whether it's going to be a graph database, a SQL database, a MongoDB database, and things like that. Inside of that container, you can have, depending on the model, stored procedures, user-defined functions, and everything you see here, triggers and conflicts. Triggers and conflict management, I should say. Conflicts you don't really want in your database. All right. And there's two important things there. The first one is a container. So inside the container, there's a collection. Inside of that collection could be one or more tables and or graphs. And inside of each one of those containers is items as well. So you can have documents, and those are the JSON documents. And you can also use rows, nodes, and edges, depending on the model you're going to be setting up for that. It'll hopefully that's a good overview, and it'll be more clear as we go through the actual example I'm going to show you in a bit. As I mentioned before, we're going to talk about request units and billing. So how we actually build Cosmos DB is this thing called request units, RUs. And they are a combination of memory, CPU, and IOPS. So there's throughput, input, output, through CPU and network, and there's also memory that gets used inside the database as well. And that's calculated in this thing called a request unit. A request unit, for example, can be a get, and that's one read of a 1 kilobyte document. A write is then 5 request units, and queries, it really depends on the actual query and what gets returned. You know, there's going to be throughput and CPU and memory that gets used depending on the query and how big the result set is that you're trying to get. So the request units are flexible. There's a calculator you can use on the site that I'll share later, and you can figure out how much the cost will be. And there is a free level, which we will be using theoretically for this example we're using today. So there's a free level that has a certain amount of RUs allowed that you can just use for that. All right, I mentioned global distribution. So global distribution, this is pretty cool. You can literally click on different locations around the world, and it will and Cosmos DB will automatically provision those models for you. It'll actually set up the containers and the databases that you want to deliver to different places around the world. So that's a really cool feature. If anyone's tried to implement any other sort of NoSQL, a non-hosted NoSQL solution worldwide, it's a challenge. And this is a way for you to literally manage everything through the service and have everything taken care of for you in terms of connections and things like that. And we'll get to security in a bit. So it's not 100% open, but it is distributed, and that's great. All right, so global distribution, a little more detail. Over on the right here is a good example of the kinds of things you can do. So you might have a website, and that website uses a traffic manager to manage the actual application. And you've got a web tier in this case, West US, North Europe, and Southeast Asia. So you've got 3 different locations. Inside of that, you might have a load balancer, which manages the actual application on the back end. And then the data on the back end, how do you actually manage that? Well, Cosmos DB will actually provision things locally for you in each one of those locations based on what I mentioned before. So you can literally just set up the locations the way you would like them for your backend database, and then you can connect to those local configured repositories to grab data from your application. So it's a nice way to scale and to distribute your application data without having to set up a lot of infrastructure. It's all managed for you. So consistency models. This is important to know. There are 5 basic consistency models, and these are based on those SLAs that I showed earlier. Strong means that your latency is lowest. Boundless statement, there's a little less latency, but more availability. Session is sort of a mix between all of those, and it really depends on your needs. So if you have an application that, for example, is updating constantly, so let's say theoretically your products are updating every second, you want to have a strong consistency model in that case, because you want the user to see the most recent data that you're using at any moment. Then you might have a bounded stateless, and that means that some of the data, you might not have a need to have multi-millisecond updates of your product catalog. You might just be able to get away with having a session that is connected to a particular application that doesn't need to be updated every second or so. One of the things you'll hear a lot when you're talking about consistency models is a monotonic read. And what that means is that the data that you're looking at any moment is the most recent write of the data to the database. Meaning when somebody brings up a new product from your database, and there's been a new write to that database, you're going to see the most recent update to that inside of the database itself, regardless of the location. So that's monotonic reads, and that's something, as I mentioned before, you'll hear a lot when it talks about consistency. And then there's eventual over on the other end, which is, you got consistent prefix, which means the data is updated occasionally. It's reasonably up to date, but it's more available. So the most recent data is more available, or sorry, the current data is more available, but the latency is a little bit lower in terms of writes. And then eventual is, when you write something, eventually it will get updated. And this is useful for logs and customer data that you'll be using to analyze later. Anyway, there's some great consistency models, and they're well explained in the ebook as well, probably better than I just did. But they allow you to have some flexibility between latency and availability. You always want high availability, of course, and low latency, but there are trade-offs to be made between those two. So there's also something called a multi-master database, and that's where all of the writes that you make to the database are updated in all of the designated master databases around the world. And the thing about that is you've got very low latency and very high availability. Now that comes with a cost, but it is available. And I just want to mention that that is there as well. So you can create a multi-master model, which is, one database is updated and all databases are updated essentially at the same time, regardless of location. Availability zones. So this is something slightly different. This is not different locations. This is backups within a single location. So when we talk about Azure and locations, typically we're talking about regions. And what regions mean is that a specific location like West Europe or West US will have multiple physical locations inside of a region. And that means for disaster recovery and things like that, the availability of the data is ensured even if one of those data sources or one of those physical locations has an issue that affects its availability. So you have regions which are actually updated with multiple different versions of your database that can be used behind the scenes, and it's seamless and transparent and completely undetectable to users that you switched from one instance in an availability zone to another if something goes down. It's just great for resiliency and for management. Okay, so security. All connections to Cosmos DB, you have to use a connection string or a third-party connection. We have Azure Key Vault, and requests are logged and available. You have firewalls, and there are 3 different connectivity models, basically. We do support TLS 1.0 to 1.2. I believe 1.0 is going to be deprecated soon. But for now, all 3, TLS 1.0, 1.1, and 1.2 are supported. So connectivity methods, when you're actually in the portal, you literally just choose from one of these 3 options. All networks means it's technically open to the public with a connection string. Public endpoint means you select certain places where it's publicly available, and private endpoint is completely closed. So we'll get into the details here. You can set up a virtual network for connectivity. Public endpoint is kind of misleading. It really should say just virtual network access. Public endpoint, so connectivity options for all networks means that it is publicly available. Like you can actually get to it via an IP address, but unless you have a connection string, you can't actually get in to view or manipulate any of the data. Then you have connectivity options in terms of the public endpoint. The public endpoint means private. As I mentioned, it's only available within a virtual network. And then inside of a private endpoint, that's where you only have access from inside very specific local internal IP addresses inside of Azure. So that's the most secure version. You have to access it through a virtual network. If you're doing web applications in general, especially if you're writing a demo like this one, you want to use the all networks option. And then if you're using something internal to your organization that doesn't need web access, you generally want to go with the public endpoint and then private endpoint for anything that is inside your organization that needs to be limited. Even from within your organization, not everyone has access to it. That's when you want to use the private endpoints. So how do you actually control access? Use role-based access controls, RBAC. You can have account management and resource management that are available through authentication through Azure Active Directory. And then data operations can be accessed through keys and resource tokens. You can also create databases and things using keys and resources. And to do that, you create what's called a service principal, and you might be using an Azure CLI or something else that's logging you in through a third party. For example, in our application, we use Postman. In that case, you'd want to create a service principal, and Postman is used through an API management to connect you via that service principal as a entity that can access the database itself. But in most cases, you're going to just access account management and resource management through the portal or the Azure CLI, where you're logged in directly to the Azure account that you're using. And then you're going to use connection strings and or private keys to get into your CRUD operations and queries and things like that. Logging is very important as well. You need an audit trail when you're working with any database. And in this case, we have some pretty good logging methods and some pretty good logging setups. And I'm going to talk to you about a couple of those as part of our example today. Here's a change feed scenario. So you have logging which stores who accessed which database at any one time, and who meaning connection strings and folks that are logged into your Azure account. But also you have a level of data changes. So who updated a product, who created a new order, things like that. And in that case, you want to use a change feed. The change feed itself can do a few things. You can actually use the built-in change feed inside of Cosmos DB. You can create a change feed in your code, or you can use a change feed based on Azure Functions and or event hubs, which is what I'm going to show you in the example today as well. There's also a way to do that with stream processing here. You can see, you can actually process any kind of trigger in a change feed to Azure HD Insight, Apache Spark, Apache Storm, and other things that you might need to use for real-time stream processing data. And that's kind of cool. So security for encryption, I mentioned TLS 1.2. It's already enforced, but you are able to use TLS 1.0 and 1.1 as well. Also, there is encryption at rest, and that can be managed. It's automatically managed by the service, and it can be managed through customer managed keys as well. And that's in a situation where you want to make sure that the data inside there is protected even from people who have access to the backend service. You would want to manage your own keys, so customer managed keys for that. You can put them in something called Azure Key Vault, which we'll talk about in part of the examples. And it just allows a second layer of encryption and protection, even from folks in your own organization. A lot of attacks or threats for your data come from internal sources, unfortunately. It's the world we live in. And so what you want to do as well, if you have particularly sensitive data that you don't want to share with the wide organization, even if they have access to your organization, the Azure Active Directory account, for example, is you can create your own customer managed key, put it in Key Vault, and only certain people have access to that. And that's using those role-based access controls that I mentioned earlier. All right, last but not least, backups. So every 4 hours, 2 backups at a minimum are stored for any active account. And even if you delete a Cosmos DB account, it's stored for up to 90 days. So there's always an option for recovery there. All right. So that's what I wanted to tell you about Cosmos DB. We talked a little bit about the model, resource units, security, and let's get back to that ebook. So basically for the ebook itself, let's see, we already covered Cosmos DB, so we can skip over that. Let's see here. Okay, we talked about security. This is the ebook, by the way. So you can find the ebook at aka.ms/Azure Spring Java Guide. And I've already covered all these topics here. So I'm actually going to move on to the example that I've got. There is I want to mention one thing. There is an example here inside of the ebook. Get started with Java and Azure Key Vault. It's totally unrelated to anything else that comes in subsequent examples that we have in the book. And so you can go through there and you can learn all about working with Azure Key Vault, but you don't need to. You can actually skip over that if you want to just get to Cosmos DB. And if you go to getting started with Cosmos DB, this is basically where I'm going to start for the examples today. So let's start at the end. There are several things that get set up here. Let's go through that real quick. So you get started with Java and Azure Cosmos DB. You're going to create a Cosmos DB account. You're going to deploy it to something called Azure App Service. And then you're going to manage some CRUD operations. And we're going to set up an Azure Cosmos DB change feed inside of there. That change feed is using Spring configuration code and also the built-in change feed functionality inside of Cosmos DB. And then we create an alternative method of change feeds. We're using a Azure function. And that Azure function can use a event hub. The event hub itself is used for sending an email to yourself telling you when something's been updated. So it's just a little simple example. So why would you want to do that? Well, there are situations where you want to create a change feed internally so you have an audit trail inside the database itself, but you might want to have some kind of change feed or notifications outside of the database as well. And to do that, it might be for compliance reasons, or it might be for safe harbor. You might not be able to have all of your data or have access to all of your data in a place where you're actually storing the change feed, that kind of thing. So this gives you different options. Also, Azure Functions are great because they're scalable, automatic, and as well as Event Hubs being scalable automatically as well. So that's two different ways to do it. You can set up a change feed inside of Cosmos DB for audit trails, mentioning anytime any item in there has changed, or you can actually create something externally using Azure Functions and or Event Hubs to do that as well. And the nice thing about that is they independently scale all those things. So, it's really easy in this example when you're just changing one item. But if you have literally thousands or tens of thousands or millions of items changing all the time, you might want to have an external log of all of those changes. All right, so let's click on, this is the Azure portal, so portal.azure.com. So I went away from the ebook now, and this is inside the Azure portal. This is a resource group, and inside this resource group is all the things that I created for this demo. And it's all the things, I followed the steps through the ebook, and it actually creates all these things for you. Let's go into the resource group, and I'll show you the resource visualizer, which I like. It sort of shows you in a more visual way all the different parts. And don't worry, I'll zoom in here a little. So the first thing we set up was a Cosmos DB account. The Cosmos DB account itself has a database inside of it and then a container. And I'll show you that in a bit. And let's skip over here. Whoops. So the next thing I wanted to show you was the app service. If I can get over there. There we go. So the app service itself is here, and it connects to an app service plan. So whenever you create an app service, it connects to a plan. The plan controls your scaling and your billing and things like that. And you can have multiple app services in a plan. Then we created the function that you need to do the change feed outside of Azure. So the application itself is running on app service. And then we have that function that I mentioned that's going to create an external change feed for you. And there is also a logic app, and the logic app itself, it sets up a different app service. And that's where you get emailed anytime something changes in your database. All right. That's the API connection that'll send the email. And there's several storage accounts here. This is one that I created by mistake. The Spring Pet Supply Storage is where data is stored for event hubs, and I'll talk about that in a bit. And basically, that's all the different components. So if we look at the overview of this, you've got several different parts here that are created as part of the steps you follow in this ebook. Now, what does the actual application look like? If I click here, I've got in my Azure dashboard, this is what Contoso Pet Supplies looks like. Beautiful, isn't it? It's got a bulk executor service. We won't get to that for sure today, but it's in the ebook, how you actually set that up. And then we've got a change feed. As I mentioned before, we've got a change feed. We've got customers, manufacturers, products, and wish lists. And basically, this is all running on an Azure web app. And this is the Azure web app itself. If I go down here, one of the nice things about the app service plan is I can scale this, and I can scale it by changing the application itself. I can scale the different, basically set up different models, including free. And I'm only allowed 60 minutes a day, so I did set up something really fast for today's demo because I don't want everyone to be waiting around for me. And then the other one was, let's see, you can also scale out. So the nice thing about this is you've got Cosmos DB, which can be scaled, but you can also do a auto scale of Cosmos DB, and you can do things like set up instance counts, add a scale condition, and it can be based on CPU. So the CPU can be set up. If you've got a instance limit, you can set up a maximum of let's say 10 instances, and you can scale based on a metric. And inside that metric, you can have your CPU. You can have specific end start dates and things like that. So you can create a rule, for example. The scale rule itself will say CPU percentage, if it's over 60-something%, add another instance, up to 10 instances. So that gives you a little idea of the app service plan, and this is what it looks like in action. And then the other thing we've got is, of course, our Cosmos DB database. The Cosmos DB, whoops, that's the app service. There it is. So the Cosmos DB database itself, I mentioned before. So this is the account that you're looking at now. If I go into Data Explorer, you can see the actual pet supplies database. This is the database. And then inside there, we have containers. And inside the containers, we have the items. So pet supplies database, pet supplies container. Inside there, we have items that we're using for this. And you can scale this as well in a similar way. So you can scale your front end and your back end. It's a nice way to actually set it up. And it's great for demos because it's easy to configure and set up and deliver. And we'll talk about event hubs and things if and when we get time today. How are we doing for time? 9:33. I think at that point, I'm going to take some questions here. Let me just check. All right. So someone there said, happy to see you. Thank you. We are taking questions. So please do add questions if you like. I am checking them every once in a while. We've got about, another half an hour here. And I'll just continue with this. But if you do have any questions, let me know. I'll check the questions from time to time. All right. So I showed you a little bit about how Cosmos DB works. I've showed you the actual components when you actually build the application. So let's go into how you actually build it now. So to do that, we'll go back to the ebook. The ebook is at aka.ms/Azure Spring Java Guide. So the first thing you want to do, you've got a couple of things you need to do. So there is a repository here. It's called Cloud Scale Data for Devs Guide. You do need to clone this. And once you've cloned this, this actually has the documentation in it, but it also has inside of demos here, the Cosmos DB demo. And that Cosmos DB demo has everything you need to basically set up the application itself. So back to the ebook. So the first thing you're going to do is you're actually going to use the Azure CLI to create a container. So for this, a couple of tips on creating things. Let me switch over. I'm going to switch over to Visual Studio Code now. This is what I do when I'm actually doing this, and this might be helpful for you as well, is I copy all of the things that I do as I go through into a Markdown file. And then I am able to sort of reference exactly what I typed last time. In this case, what I'm actually using, this is a Windows machine, and this is Visual Studio Code, and I'm using Windows Subsystem for Linux. So I'm using Linux. One little caveat for the ebook is when you create, you do have to set some environment variables here. And inside the ebook, it's written for a Windows developer. All you need to do is add export to the start of your variable declarations if you're using, as in my case, Windows Subsystem for Linux, or a Mac terminal or any kind of Linux terminal as well. The options here you have inside of Visual Studio Code are Ubuntu. You can use Azure Cloud Shell as well, but I don't recommend it for this because you do have to access the local repo to run the Maven. It needs to have access to the POM, and it gets a little bit tricky when you're building things if you're using it from Cloud Shell because you're technically in the cloud. You can still clone things, and you can work with them inside of the Cloud Shell as well, but I found that for this particular demo, it was easier to use WSL. In this case, I'm using Ubuntu 20. There is also command prompt, git bash, PowerShell, and a few other things. So, but I just used the command prompt for this. All right. So the first thing I did was actually just create the Cosmos DB database, and that's using the Azure CLI. You do have to install the Azure CLI if you're using any local client. It's actually built into the Cloud Shell. But for this, you do have to install it. And there's instructions on how to do that in the ebook as well. It is one of the prerequisites you'll need. So the first thing you do is use the Azure CLI, AZ Cosmos DB create, and you name it the Pet Supplies demo. The first thing you do actually is create a resource group. And that's, if I go back to the portal here, portal.azure.com, this is a resource group. So this has everything in it, and it's a lowest common denominator of working with Azure. You do need a resource group for pretty much everything. So you say AZ group create, and in this case, I created it in East US. Once you've done that, then you can say as AZ Cosmos DB create, you create a account called Pet Supplies Demo inside of that resource group that you just created. And you can say enable free tier true. This is something that came up for me, and it's unique to Microsoft employees, is for my particular account, I'm not allowed to use the free tier because resources, especially free resources, are for customers. So I had to set up something that was standard. And I mentioned the consistency level. You saw that as part of the presentation. We set up the default consistency level of session. And that was that one right in the middle that gives you the balance between high availability and latency. Once you do that, then you create your database. So I mentioned before, there's a account, database, and container. So AZ Cosmos DB create. And by the way, when you create Cosmos DB, you do have to give it a unique name. So you'll have to add something unique for that. I just added the date that I actually created this. And then the AZ Cosmos DB SQL database create. And I mentioned before at the container level is where you decide what model you're going to use in your multi-model database. You could be MongoDB, Cassandra, etc. We're using SQL. So we use a SQL container and we use the account name that we set up, the database name that we set up, and we call this one pet supplies. And there's a partition key path, which is document key type because we're actually just using documents inside this database. All right. So once you've set that up, I mentioned you do have to set up some variables, and those have to be set up so you can do the next part of this, which is running the application itself locally and then deploying it to an app service. You export Cosmos, the URI that you're going to use for Cosmos DB and the key. So this is the way that you actually have your private connection information for your application that you're going to be using. And then basically, once you've got that set up, you do a Maven install, Maven Spring Boot run, and localhost 8080. And this goes from the demo that you see here. So if I go back to the GitHub repo and I go into the demos and Cosmos DB demo, this is the code you're actually using, and this is what you need to use to actually run this demo locally. So once you've done that, you can do a Maven install, Maven Spring Boot run, and then you can access the application localhost 8080. It looks exactly like the one I showed you earlier. And then what you do is something kind of unique to Azure. If you're familiar with Maven and Spring, we actually have something inside of Maven that's been custom built to deploy this out to an Azure web app. And that's Maven package Azure web app deploy. And let's look at the POM, and it kind of explains what that does. Let's bring this down. So this is the POM.xml. If you use Spring at all, if you're using Maven, you'll be familiar with what a POM.xml is. In this case, I use Java version 11. We call the app Pet Supplies app. We have an Azure version, which gets automatically defined for us. And then the web app name, that has to be unique as well. So you specify, in this case, the web app that you're going to be deploying to. In this case, I added just the date that I created it on. The service plan, you create an MS Cosmos DB Java guide. The location you specify. And then you have the resource group you're going to put this in and the web app version you're going to use. And then there's a bunch of dependencies here. Everyone's mostly familiar with those if you've used Maven before. But basically what that Maven deploy will do, the Maven package Azure web app deploy, it'll take that application that you've created locally. It'll create the web app that you specify in the POM.xml. And then it'll actually create the database that you need. So if I look here, the result of what I did is here. So this is the Cosmos DB app service, and it's part of the app service plan that we had already set up. It's in the resource group that we had set up before. The resource group app service plan is called MS Cosmos DB Java Guide. I mentioned before you can have more than one of these. So that's the idea here. The app service itself, it has the basic information that I showed you before for scaling, and it connects to the Cosmos DB database via that connection string that you specify as an environment variable. That gets passed along with the application, and it actually sets it up inside of your configuration inside of the app service. If it opens. There it is. So you got the Azure Cosmos key and the Azure Cosmos URI. Those match the values that you set up as environment variables, and those get picked up by the POM.xml when you're passing this using that Maven web app deploy command. Where are they? There's the Azure version. I'm looking for the actual, there it is. So these properties get set up in the app settings section, and they deploy the Azure Cosmos URI and the Azure Cosmos key, and they actually set it up as connections inside of that app service for you. So anytime you scale, it's going to use those same ones. All right, so that is basically the section here, Get Started with Java and Azure Cosmos DB. You clone the repository, you set up those environment variables, you get the Azure Cosmos URI, the Cosmos key by specifying the environment variable settings. You set them up in that pom.xml. You do a Maven install, then you run it, and then you deploy to Azure App Service. And to do that, you just need to make a couple of changes that are outlined in the ebook. The app name I mentioned before, the service plan, which those get created when you specify them if they're not already created. And then you specify a region and the resource group that you're using. And that's it. Then you deploy that application, say Maven package Azure Web App deploy. And that is essentially all you have to do for that. It's fairly simple. You can also use something like GitHub Actions to do the deployment itself, but this is just a nice, quick, easy way from Maven, from your command line to deploy that as well. And it's something that's been custom built. Let me just check on questions. Okay, no questions. Yes, there are some. If you check in the comments, there are some resources there for today's session. And we are using the ebook at aka.ms/Azure Spring Java Guide. So the next thing is CRUD operations. And this is just telling you how the actual CRUD operations work. You can check out the ebook for that. We've only got about 15 more minutes, so I want to get through some of the tips for actually deploying this stuff. And you can see how the actual CRUD operations work inside the application. There's a good description of it here in the ebook at aka.ms/Azure Spring Java Guide. All right. And then the next thing where you actually need to do something is you want to set up a change feed. And the change feed itself is an Azure Cosmos DB built-in feature that allows you to track changes, basically. It's good for audit tracking and things like that. And you can use the change feed for updating anything that you specify, actually. And to do that, what you do is you set up a separate container called lease. Let me show you that. So we'll go back to the portal here. And if I go into the dashboard, you're going to see Cosmos DB. And we go into Data Explorer again. And you can see inside the Pet Supplies database, so this is the account, that's the database, we've got a new container called lease. And inside the lease, this is where any items that actually change are stored. So any items, if you change a product, things like that, these are stored here automatically, and it's great for audit trails and things. And it's consistent again. So it follows your consistency model that you specified, and it replicates globally depending on how everything needs to be set up. And it automatically backs up using the features that I mentioned before, the replication, the high availability, the availability sets, and the backups. So everything's in there, and it's part of your database, which is nice. So let's go back to the ebook and show you how to set that up. The first thing you do is just create that lease container, and you use the Azure CLI for that. Let me go back here. So in that case, you do AZ Cosmos DB container create in the Azure CLI. You put it in the same resource group. You set up the account name that you're going to use. In this case, 2023 uses the date I created this, the database name, and then the container that you're going to use for this. And the name is lease, and the partition key path is ID this time. So last time it was document. This time it's ID. So documents were just used for general information about products, services, customers, things like that. In this case, because it's a change feed, it's better to be tracked via the ID. Then you have to basically from there, you can see what happens. So it actually creates something in the JSON in application default properties that you're going to use for the application. And from there is a new gateway connection config that gets added to the code. And basically from there, every time there's a change in your application, it's going to write something to that lease container, any data that you have in the application itself. All right, so that is basically how you set up a change feed inside of Cosmos DB. And I mentioned before, there is another way to, I got to get down to the bottom of this so I can move on to the next section. Okay, so there is another way to create a change feed, and that's using an Azure Function app. So in this case, Azure Functions are, if you're familiar with AWS Lambda or any other serverless technology, basically here we're creating Azure Functions. Azure Functions are a way to basically trigger something. In this case, anytime there's a Cosmos DB change, you want to trigger an update, and that update is going to send data to an event hub, and that event hub is then going to trigger an email that gets sent to me via a Logic app. The reason why you want to do this, as I mentioned before, is inside of Cosmos DB is great for tracking things, but you might have sometimes when you need to have a separate, for compliance reasons or something, you might have a separate audit repository that you need to use. And the Azure Functions are a nice, clean, flexible way to do that. And it scales along with your Cosmos DB as well. You can set up scaling for that as well. So setting that up, basically you have to create a storage account. The function uses a storage account to process any changes that happen. And then you create an environment variable called Azure Web Job Storage, and that connects to that. From there, then you need to use your Cosmos DB connection string, which was used previously. So you can set that up as well. From there, you run this command. It's another Maven command from your command line, and sets up an archetype, which creates an Azure function for you. And it actually populates a whole structure inside of your repo. So if you need to set up a new directory before you run this, and then what happens is you answer a whole bunch of questions here. What do you want for the group ID, the artifact ID, the version control? In this case, just use that format. Then the package you're going to use, this is the package that gets generated for the Maven archetype for the function, com.function. And then you name the app Cosmos Change Feed Processor Function. You set up a region you're going to use. You use the same resource group we've been using for all the demo. You set up a new app service plan. I call it Java Function App Service Plan. And then you choose your Java version. I went with 11, although 8 is the one that most folks are still using for functions. You have a trigger. So the trigger is Cosmos DB trigger. And basically from there, it's actually going to create that for you. You can test it by saying Maven, you change the directory to function, say Maven clean package, and then function start host. And that's going to run it locally. So you can make sure there's no bugs or problems with it. And next thing you want to do is inside of that, you want to set up a new set of variables inside of your pom.xml, the Azure Web Job Storage and the Azure Cosmos DB connection string. That's going to store the data that gets triggered by the Cosmos DB trigger. From there, you do a Maven Azure Functions deploy. This is very similar to the other functions deploy that we had. And basically what that does is it deploys this application out to an Azure function. And then from there, you can also use the command Maven install package Azure Functions deploy. That actually runs the package and deploys at the same time. And it sets up inside of the properties, just like the other one, the Azure Web Job Storage and the Azure Cosmos DB connection string. So if I go into the actual function itself, you can see that here in the portal dashboard. Let's go into the resource group. I can't see everything there. That's storage. Oh, it's in a different resource group. Sorry. It's in a different resource group that I've got down here. Nope, I don't have it here. This is the function app. Anyway, there it is. The function app itself is slightly different from the other web app. Because it has functions built into it, but it has an app's endpoint, and it has the configuration just like the other one with the values that you've set up for the deployment. So once you've got this deployed, it's running, and anytime that you set up anytime that you have a change in your Cosmos DB database, it'll actually trigger the change here as well. So you set up the Azure CLI, you set up those connection strings, and then you say generate, the instructions are here. Deploy the function to Azure. Don't forget to add your properties, just like we did before for in this case, the storage and the connection string for Cosmos DB. And once you deploy this, then you don't actually need to set up this as well. This is Azure Function App Config App Settings. So this actually gets set up automatically by the pom.xml when you deploy this as well. So it's not something you need to do. This is just to confirm that your app settings are there. And they should be available inside of the configuration as well. So real quick, we just got a couple more minutes here. So the event hubs is the next thing you want to set up. You set up the event hub, you create a namespace for it. Let me just switch over to my script here. So the next thing you want to do is, that's the function, that's it. So you set up an event hub, AZ event hubs, and you create a new one called Pet Supplies Events. Use the same resource group that you had before. Oh, one important thing, the location of your storage for your event hub and your event hub have to be in the same location. Otherwise, it will fail. So that's an important tip. You create the event hub itself. Then you create the namespace. And then you create an authorization rule. And the authorization rule allows you to connect from the Cosmos DB database, or sorry, from the Azure function into your storage. And there's rights here, which are listen and send. Once you've got that, you can set up a Event Hub connection, and that Event Hub connection will connect to your storage account. So if we look at what this looks like in the portal, and we'll be wrapping up in a second here. We'll continue this in another instance here. But if I look at what this looks like in the portal itself, what it does is it creates this event hub. And then inside of here, it sets up the access that you have. Inside of the event hub itself, there's a Pet Hub event. Inside of there in here is the authorization. Don't look at that. That's the authorization that you use for connecting to the storage. So anytime that there is a change in your Cosmos DB, by the way, that there you didn't see the whole auth key, so it still goes over to the right. Anytime there's a change in your Cosmos DB now, it's going to trigger that lease container inside of the application for Cosmos DB, but it's also going to trigger this function, and that function is going to feed event hubs, and then it's going to be triggering a logic app, which sends me an email whenever anything changes. And I think that's all the time we have. It's 10 a.m. and hopefully that was useful. Let's check for any questions. I don't see any here. In the comments, please do fill out the Reactor survey. Love to get some feedback there. And check out the ebook itself at aka.ms/Azure Spring Java Guide. All the information is here. So hopefully this video combined with the guide is very useful for helping you set up the demo application that we have here. So we set up Cosmos DB, we set up Spring, and we set up a Spring app in Cosmos DB, event hubs, storage, and other things. I'm hearing some background noise there. All right, folks. So if there is any other questions, here's some resources you can use. You can find me on Twitter at bbenz and Mastodon at bbenz@mastodon.social. Please do let me know if you have any questions.
All right. Well, thank you, Brian, and thank you all for joining. If you do have any feedback, we would love to hear what you have to say. You can find the survey link in the chat. We'll put it up on the screen for you as well. And I'd like to thank you and have a great day.
Thanks.